This next unit we're going to be working on is dealing with exponential functions and logarithmic functions. Now, those can both sound very intimidating the first time you hear them, but actually they're very straightforward, especially the beginning parts of them, which we're going to be working on in this unit. Now, as you move into pre-calculus, clearly this will get more advanced and a little bit more challenging, but for what you're going to do in this unit, everything is really very workable and very straightforward. It's just a matter of getting over a few hurdles here. Now, the first few lessons will be dealing with the exponential functions, and you've dealt with exponential properties before, and an exponential property has a base raised to an exponent, and so you're used to seeing something like x squared, where x represents the base and 2 represents the exponent. Well, an exponential function is a little bit different. An exponential function has a numerical base with a variable exponent. So the b represents the base of the exponential function. So we could have something like 2 to the x power. So this, if we wrote this in function form, would be an exponential function. Now, keep in mind, whatever value is being raised to the exponent, that is the base. And so we would work off of that. Now, just like any other function value, that base can be have a multiple, and so you could say that we have the b to the x could be multiplied times an a value. And if you remember, our a, x, and k, our a, h, and k values for when we do transformations, that a value comes into play. Any exponential function can be either what we call a growth function or a decay function based on the value of b. So if you look here, and you can see what this would look like from a graphical standpoint, exponential growth from left to right increases exponentially, as we would call it, and an exponential decay decreases exponentially. Now, if you notice, the x-axis is an asymptote. So you have experience with the end behavior using asymptotes. So if you look down here in this concept box, you'll get a quick view summary of everything regarding growth and decay functions. And so you can see if the b value is greater than 1, we have an exponential growth. If the v value is between 0 and 1, we have exponential decay. So let's take a look at a sample problem here. Sample problem number 1. If you go ahead and take a second to answer A, B, and C. Okay, so if we're looking at this, we're looking for a times b to the x power. And to determine if it's an exponential growth or exponential decay, we want to look at the b value, and that's what the hint in the problem has given you. And so if you look at part A, we're going to look at the b value there. We have 2/3, and we know that it's between 0 and 1. So that is a decay function. Now the next one's a little tricky. We have 3/2, and it's in a fractional form, but that 3/2 is actually greater than 1. So since it's greater than 1, we know that that's going to be a growth function. The last one actually needs to be rewritten. We can see here that it's 10 and it's 3 to the negative x. To make that a positive x, we would make that to the 1/3 raised to the positive x value. And so now that we have 1/3 as a b, we know that that is a decay. Alright, so that should be a good quick introduction to exponential growth and exponential decay. As always, it's good to read through these notes in full, since I'm not addressing every single word that's being written in the notes. In the next video, we'll talk about graphing exponential growth and decay functions.